Hello everyone. Today we are going to do some analysis from the scratch till the end using Python. So first, I already opened Jupyter Notebook using Anaconda, and first we need to import some libraries to do analysis. I imported NumPy, pandas, and matplotlib and seaborn. So let me run. Okay, then I'm reading. I have a dataset. I will provide the link on the below, like on the comment section, to my GitHub, so that you can also use the same data, or you can use this notebook as well. So I'm reading the data, and it looks like this. So we have a time when it's asked from people. So it's a survey of 30 people, their gender, study year, which departments they are studying, and how many devices they have, their grades, increase or decrease in their grades, and average hours spent on electronics, and what is the purpose of using the device or buying the device. So if we look the information about the features columns, we have time step. So this is time when it's asked, and it's object. It's not actually a time series now. It's just as can be considered as a string. Then we can see that we don't have any missing values, and actually we have very our number of servers is low, 30 members, but actually we can still do some performance on that, so it's okay. Only column we have number is how many electronic devices do you use. This actually this can be a number also, but we have a postgraduate, so it will make all of our numbers as a strings, and because we don't know which year they study, and this also can be string, but it's provided as a between line space, like from 4 hours to 6 hours. So we can make it average for example 5 hours, 2 hours, 5 hours, 2 hours, like that. We will see them later. And if you see the columns, it's so hard to call them one by one because it's so long, and it's readable, but it requires more code. Python should be less code and more readable as well. So I am changing my columns, all of the columns in one go, by providing a new list for the columns. So techno.columns equals to the list. Note that the list should be equal to the number of the columns. The number of items in the list should be equal to the number of columns. So time instead of time step, gender instead of gender, study year instead of your study year, and at the end purpose instead of what is the purpose of buying the device. So I'm changing the column. So if I run this and see, now my columns changed, and I can see the time, which is this, is object, but I should change it to date time series. So how to do is pd.toDateTime, and you will provide the column itself, and I'm assigning this change to that column exactly, so that my time column will change to the date time. Now if I see, we don't have any backslash, and we can do some performance on this column also using the datetime features. The next thing is, as I said, we have a mean hours, but it's also the string object type mean hour, and we can't do any performance with that if this is the case. So I need to change it to integer or float so that I can do some analysis. So what I should do is, so let's forget this part, techno daily hour part. So I'm starting from here. So what can I do is I can separate this 4, 6 with this sign, with a minus sign, and I can add this 2, 4 and 6 and divide it by 2. It will give me the exact mean hours. So in this case it's 5. For this case 1 plus 3 divided by 2, it's 2. So what should I do is I should take 4, I should take 6 separately, then I will add them up and divide it by 2. How to do is, so I'm calling techno mean hour this column, then I'm saying that take the values as a string, then split them by minus sign and expand it to true. So if I don't expand it, when I split, it will split 4 and 6, but it's still in the same list, so we can't separate them. So expand equals to true, expands it into 2 columns. If I have 3, for example, it will separate these values into 3 different columns. And I'm taking 0. If I expand this, the first column will be 4 and the next one will be 6. So from these 2, I'm taking the 0 index. 0 index means this one. For the next one also, it will take 1. The next one 4. The next one 1. It will take this 0 means this. I'm taking 0 and change it to the integer. Because it's still string, I'm changing it to the integer. Then I'm adding this to exactly the same formula, but the next time I'm taking 1 instead of 0. 6, 3, 6, 3, 6. And I'm taking this also as integer. So I'm adding this 2 up. So 4 plus 6. 1 plus 3. Then overall dividing it by 2. So my bracket starts from there until there, then I'm dividing it by 2. So it means I'm taking the average. So if I run this, we can see techno. Let's see the techno itself. Daily hour. So it gave me the daily hour, 4 plus 6 divided by 2, 5, and the rest. Okay, the next thing we should do is we can do some performance on our new created column daily hour. And let's see, we want to see, we have a gender, we have daily hour. Let's see whether daily hour usage of gadgets affects on GPA increase according to the gender. So if my gender is male and if I use more gadgets, maybe my GPA decrease, but if I'm female, then if I use more, maybe my GPA increase. Let's see something like this. So what I should do is pivot table like those of Excel formulas, techno the data, I'm using techno as a name of data frame, so you have to provide data frame name here. As an index take gender. So here, for example, my index 0, 1, 2, 3, 4. So instead of like when we create pivot table, it will give gender there. So I have two gender, female and male. So there will be two gender. Then columns, as a columns, GPA increase. So GPA increase inside, increase or decrease maybe other values. So it will create new columns according to them. For example, increase one column, decrease one column. And if I have any new variable, it will create this column also. The next thing is values. What value should I use? I'm saying daily hours. So it will give me daily. It will take daily hour and assign it to every column and row by row and column by column. So first let's run this, then we will see what I mean. So here egg-func means what mathematical method do you want to use. I wrote it count, but actually it should be mean, because I'm taking the mean of daily hours by genders. I will mention the plot size and later. But if I see the graph, so male whose average hour is 8 hours has both increase and decrease. But female who have used mobile phones more said that their GPA decreased compared to those who said increased. There are more females who said their GPA decreased. So this is one thing we can do. So here actually if I delete this part, from here it's creating a graph, but if I delete this, you can see what pivot table gave. So GPA increase, non-decrease. So according to the gender, it's providing the daily hour average for female and male for increase, non-decrease. So then I plot it, and what kind bar chart, horizontal bar chart, and I'm assigning the figure size, and these things is just providing labels. So you can see this is one. Okay, then proposed frequency. So what I'm going to do is here when we asked like why they using, when we asking why they using mobile phone or why they bought mobile phone or gadgets, like they answered like multiple choice: studies, entertainment, phone call, here online class, games, online class, and the rest. So I can separate this. Like for example, there are studies everywhere, for entertainment everywhere, online 3, phone call 2, like this. So I can count this one by one. So what I should do is I should separate this by commas, and I will when I separate, I should assign all of the new variables to new list, and I should count which one is higher, which one is lower. So here I'm doing the same thing like we did for when we divide this into 2. I'm taking purpose column, assigning as a string, then splitting by comma, and I'm expanding it through, so it will separate every values into new columns. Then stack means it will, when I have column here, this, for example, let's say we have this 2 column, study year and gender. When I stack this, study year 4 goes to the lowest part of the gender, and graduate post goes to the lowest part of the gender next. So that time my lowest part was 4, then graduate post goes to the, just taking this column and adding this. So stack, so it will give me 1 column of all variables, and I will count the values here. So if I see studies 29, entertainment 25, and online class 20 and 1. So online class and online class, like there is a space here, there is no space here. We can work on that, but we don't need to do it now. So creating a pie chart. So let's create a pie chart. If I see it's PLT pie, I'm just providing the list, but we can actually adjust this. So here, if you see 929 is for this part, but actually we don't know yet, so we need to assign values. PLT figure fixed size, it's adjusting the size. Proposed frequency, as we did before. Then we are adding new parameters to make it more insightful. So auto stay means assigns the values. So it's 29, so it will assign 29. Actually not 29, it will add all this up and divide it by 29. Then it will give me the percentage. Explode means how far this part of pie charts should be separated. And labels, so for labels, what should I say? I'm providing the index of this. So index, studies, entertainment, phone call. If I run this, you can see that studies 25%, entertainment 21%, phone call 20%, like this. And the next thing is, let's see this plot, actually histogram. If I run this, essentially this plot data I should provide. So what column I'm going to see this plot as histogram is not number of gadgets, and beans 0 to 6. So this is the beans. This is a frequency of number of gadgets. So we can see that 3 gadgets is more 2 to 3, actually it means 2. The number of gadgets on the people is more likely to be 2. Means if I provide KDA equals to true, it will give me the normal distribution of my histogram, but actually we only have 30 values, so it doesn't give us much because our sample is so low. So this is it, just to see the frequency of number of gadgets. The next thing, I'm doing the same like pivot table like we did here, and I'm going to go in detail for this one, but I will explain what I did. So as I said, data, then index. For index, I'm asking to be study year, column gender, values daily hour. So when I don't provide the which math function to use, the default is mean, so it will take the average. Then I'm plotting it and providing it as a kind as a bar. So we can see that for study year, first year, second year, third year, fourth year, postgraduate, and gender, female, male, female, male, female, male, female, male, and daily hours spent on gadgets. So let's see. For the first year students, if the student is female, it's more likely that she's spending more time on gadget compared to male. But the next year and the next year and the first year, male is spending more time on gadgets. But when it comes to postgraduate again, female taking the dominance and spending more time on gadgets again compared to males. And on the first year, it seems like most of the females, also males, tend to spend more time on gadgets compared to other years. So yeah, this is also one type of analysis. Next thing, let's see. So for departments, how many number of gadgets? For if a student belongs to one department, how many gadgets he or she is going to have, or she owns. So this will show. So I'm taking these two, department and number of gadget, and I'm grouping by department. So this is the department, and I'm taking the mean, which is this mean, and I'm rounding it because sometimes it will give 2.5, 2.4, so rounding it makes sense here. And I'm sorting the values by this row, by this column, and ascending false means it's in a descending order, so from highest to the lowest. So for business management, students more likely have 3 gadgets: creative industries, information technology also 3, and the rest is 2. So we can assume that business and the information students, department students, tend to own more gadgets than others. And also we can do the same thing with recent grade, GPA. I'm taking so let's first see what we have. Techno, that heat. So recent grade is 3.49. So I'm grouping by this, and I'm taking the mean of daily hours. So it means that for recent grade holders, for different recent grade holders, how many hours they're going to spend. So if I say 3.5, the highest grade holders, number of gadgets have only 2, and daily hours spent is 7. And we can see that for the lowest grade holders, their number of gadgets is 3, and they tend to spend almost 10 hours a day. So we can assume that using more or holding more gadgets and spending more time on it will affect your grades. Also, the next thing, we can assume that if you own more gadgets, then you are more likely to spend more time on your gadgets than those who own less gadgets. So actually we can compare that if you have two gadgets, your spending time average is 7 hours, and also if you have 3 gadgets, then your spending time is 7 hours for this case, but for this case it's not the same. So those who get the lowest grades have more gadgets and spend more. This is the last of our small analysis, and we are going to do more analysis on our next videos. If you have questions, you can ask me on a comment section below. Thank you for your attention.